Okay, so before that, in part A and B, you would have realized that OD is parallel to AB. OD parallel to AB, and the vector OAB is negative 2A plus 4C, which means that AB is actually twice of OD. Okay? This is what we have obtained from part A and part B. So if the vector AB is twice the vector of OD, it means that the magnitude of AB is double that of the magnitude of OD. Okay, so now armed with this information, let us now sketch out the triangle for OAB. So OAB, this is our triangle over here. This area over the area of OAD. Okay, so red triangle over green triangle. Now, when we are trying to find ratio of areas of figures, in this case triangles, what are some options that we have? Okay, we can consider the height, we can consider the base, we can consider whether they are similar or congruent triangles, right? Okay, so let's start. Are they congruent triangles? No, obviously not. Are they similar triangles? Also not similar triangles. Just to recap, if they are congruent triangles, they will have the same area. If they are similar triangles, then the ratio of area will be the... If they are similar triangles, the ratio of area will be the square of the ratio of sides. Okay, that's a recap. Now in this case, they are not similar, they are not congruent. So our next strategy is to check whether they have the same base. Because if they have the same base, then the ratio of area will be ratio of height. Okay? Because half, for example, these two triangles, they have the same base. So the area of the red triangle will be half times base times height. Then the area of this green triangle will be half times the same base, it is the same half, times the same base, times a different height. So in this case, same base, different height, ratio will be just ratio of height. In other words, the answer to part C is the ratio of height for this triangle, the bigger triangle, to the ratio of height of the smaller triangle, because they have the same base. Alright? So the question is, what's the ratio of this height to this height? 2:1. How do we know?
Because already find AB is equal to
AB is double the magnitude of OD. Does that therefore imply that this vertical height is also double of this vertical height?
Yes.
Yes, it does. Okay? We can see with our eyes, or we can work it out mathematically, or we can use logic. The vector OD over here is a certain number of units to the left and a certain number of units up. The vector AB is the same certain number of units over here to the left, but you double it. Okay? And then it is a certain number of units up, which is double that of the units upwards for OD. So their heights also have the same ratio, which is 2:1. Therefore, the answer to part C is just 2/1. No working required. Can? This is the next question. 14. Okay, take a look at your working. Do you need help with any part? Part A. Part 1, 2, 3, and 4. Expressing these vectors in terms of A and B. Need help? Which part? B. You mean part 2 or part B? B, okay. Before that, do you need help with part A? Part 1? A part 1? Part 2? Part 3? Part 4? Matthew, which part do you need? 2, 3, and 4. Okay, let's start with 2. OE. By the way, what's the answer for OD? 2/3. Okay, let me show you how I do this type of question. Because there are a number of ratios all around the place. what I need will be a multicolored pen. Cosby, Shihan, Racy, please look up. I think a multicolored pen is useful in this case because there are many ratios all over the place. D is a point on OB. D over here is such that OD to DB is 2:1. OD is 2. DB is 1. By doing this in green, I know that this 2 is related to this 1. Okay? Next, I will change color because I've got a couple more different ratios. Okay, so now red. E is a point on AB, E over here, such that AE to AB, AE to AB, AE to AB is 2:5. Now, should I write 5 or should I write 3 on the diagram? I will choose to write 3 over here. Okay, so from here I can see clearly already AE to AB is 2:5. But if I were to require AE to EB, I know it is 2:3. Get it? And the final one, DE is produced to F, such that DE to EF is 2:3. Okay, choose another color. DE to EF. This is 2 over here, and this is 3. So with this notation, with these colors, I know which ratios are related. And I can very easily write one in terms of the other, as long as the vectors are related to each other. So OD, since we are required to go through part 2, 3, and 4, I'll just do part 1 as well. A part 1. OD, looking at the diagram, OD is 2 units out of 3 units of B. Right? Because of the way I write it, 2 and 1 over here, I can see that the whole thing is 3 units. And 3 units will represent the vector B. Okay, so OD is 2/3B. Done. Now part 2, OE. O to E. Quite a number of paths I can take. O to A, then A to E. That's one option, isn't it? But can we find AE easily? Can we find AE easily if I take this path? Not really. But is it possible? Yes. AE is 2 out of 5 of AB. But can I find AB? Yes, I can. AB is negative A plus B. So yeah, I can do that. That is if I want to find OE. But is there another way? How about O to D? Then D to E. Can't really do that because I don't know what is DE yet. But I can go from O to B, then B to E. These are the 2 options we have. Okay, so let me just use the second option. This is now O to E, from O to B, then from B to E. This is one possible path. Then now I'm going to work on each individual problem. OB is given to be simply B. Now BE, according to my red numbers over here, the red ratios, BE is 3 out of 5 of BA. 3/5 of BA. We're doing it very, very systematically. Okay, so now we need to find out what is BA. Carry on. This is B plus 3/5. Now BA is from B to A. From B to A means I go from B to O, then O to A. B to O, then O to A. I have OB, therefore I must have BO. So this is from B plus 3/5 negative B plus A. And simplify. B minus 3/5B, 2/5B plus 3/5 of A. You can leave the answer like this. You can also choose to take out the 1/5, 2B plus 3A. This format, the factorized form, is useful if in the subsequent parts we need to prove vectors are parallel. We need to show that these two vectors have a relationship, state two characteristics, two properties, this second format will be more useful. Otherwise, this format is also okay. Next, part 3. DE. To go from D to E. D to E, I can see two different paths I can take. Either D to B, then B to E. Now D to B is just 1/3 of B. B to E is just 3/5 of BA, both of which we already know. The other approach is from D to O, which I can also find out, it is -2/3 of B, plus OA, then I plus 2/5 of AB, which I can also find out. But the first option has fewer paths, right? Let's choose the first option. DE is D to B plus B to E. Now DB, according to the green numbers, it is just 1/3 of B plus, now BE. I think we have done that earlier on. Over here. This is my BE. Right, just quote this down. So this is minus 3/5 B plus 3/5 of A. Simplify. 1/3 B minus 3/5 B. We get -4/15 of B plus 3/5 of A. Okay, so here we can again factorize. Take out 1/15, we get -4B plus, is it 9? Plus 9A. Let me check, 3/5, yeah, correct. Okay, so this is our expression for DE. Any questions so far? Okay, let me highlight this over here. Now this is the alternative accepted final answer, and the way I write it is such that inside the bracket I have integers. Outside the bracket will be a scalar multiple. This scalar multiple will either be a fraction or it will be another integer. Okay, but the key is within the bracket it should be integers for us to be able to easily compare later on. Okay, since I'm running out of space, I'll just write down some of these answers. 2/3 of B, but 2/5, 2B plus 3A. Please help me check the answers because I'm doing this from scratch. So if I make a mistake, you have to let me know. And the last one? DF. From the blue numbers, DF is 5/2. 5/2 of DE, which is found in part 3. 5/2 of DE. DE is 1/15. -4B plus 9A. Okay, go and simplify. You get 1/6 -4B plus 9A. So that's DF. So for part B, what is the relationship between OA and OF? OA is over here, and the other one is OF. What does it look like to you about these two vectors? Parallel. OA and OF, they appear to be parallel. These just look like only. So if you think that they look like they are parallel, then you should go ahead and prove that they are parallel and see whether it is true or not. Besides that, what else can you tell about these two vectors? These two vectors lie on the same line, right? It appears to be so. We'll try and prove it later on. What else can we say? we can talk about the magnitude. What is the relationship between the vectors? Oh, vector OF is how many times of vector OA, right? That is also possible if they are parallel. So let's go ahead and prove all these things. To do that, I need an expression for OA, I need an expression for OF. Do I have the expression for OA already? Yes, it's given. OA is just A. What about OF? So we need to find it. OF is the same as from O to D, then D to F, right? We can find that. OD, then DF. Of course, there are other paths that you can take. You can go from O to B, B to E, then E to F. You will still get OF. But you must choose one that is easier for you. I think OD plus DF is straightforward. Now OD, comparing the green color, will be 2/3 of B plus DF, which we found earlier on, 1/6 times of, okay, since I'm going to be working it out, right? Let us expand straight away. Minus 2/3B.
So why still you put the underline even though they already give you AB? Or is maybe?
Huh?
Even the given or is more, we must put underline.
What do you mean underline? You mean this squiggly thing?
Yeah.
That is to denote it is a vector. If you don't have it, it becomes a scalar. Okay, so I'm still expanding my DF. Negative 2/3 B. 1/6 times 9 is positive 3/2A. So this is my expression for OF. And hey, look, the B disappears. They cancel each other off. Are you surprised? No, you shouldn't be surprised. We are expecting OF to simply be in terms of A by itself. Now, yes? What did the answer say? In the answer key? What did they say is 2 times? OF is 2 times of OA, is it? Did you all get 3/2A for OF? Then you are correct lah. Textbook wrong. Okay, if the textbook say that OF is double of OA, then textbook is wrong. Okay, because we have calculator, right? And do you see any mistakes over here? No, I don't see any mistakes. 3/2A, yeah, correct? Okay, so this OF is 3/2A, and right now I'm going to express it in terms of OA. This is 3/2 of OA. Now look, this conclusion over here is that OF is equal to 3/2 of OA. What does that tell you about OF and OA? They are parallel. Besides them being parallel, what else can we tell? They are on the same line? How do you know? There is one common point plus they are parallel. Okay, what is the common point? O, yes. So they are on the same line. What else can we tell about these two vectors? Magnitude. We talk about magnitude. So in vectors, you have two things, right? Magnitude and direction. So direction-wise, we are talking about whether they are parallel or not. In this case, yes, OF is parallel to OA. That's one thing. Then we talk about magnitude. OF is 3/2 times OA. Talking about magnitude only, yeah. And there's actually a third thing that we can tell from this. Because they are parallel, plus there's a common point O, therefore OAF are collinear. They lie, these 3 points lie on the same line. These two vectors lie on the same line. Get it? Collinear means on the same line. Okay? So to answer part B, what is the relationship between the vectors OA and OF? OA and OF lie on the same line. Now this statement over here tells us that these two vectors are parallel, plus they have a common point, which in this case is O. If I want you to state another fact about OA and OF, what will you say? Okay, so listen up. This is one conclusion I have. OA and OF, they lie on the same line, right? They lie on the same line. If I want you to tell me another statement, another relationship between these two vectors, what will you talk about? Will you talk about the magnitude? Will you talk about direction? What will you talk about? Think. This is one statement already. If I want another statement, obviously they cannot overlap, right? The two statements should not overlap, otherwise it should be counted as one statement only, isn't it? So what should we be talking about now? Magnitude, yes. Okay? Because in your next line you say that OA and OF are parallel, yeah, you are correct, but it is already a subset of the first statement, isn't it?
So,
yes?
Isn't you writing OF equals 3/3 OA really statement?
This over here is a mathematical equation. From here we interpret two characteristics. In fact, in this case, there can be 3 points that we can make because there is a common point. Okay, this is an equation, and then we have to interpret this into two facts. This is one that we can write, the other will be magnitude. Yes, Suan.
Oh, can I write that they move towards the same direction and
Wait, don't say move towards the same direction. If you're talking about same direction, you tell me same direction.
same direction and like they are parallel. So it's like two different sides.
Same direction, but parallel. Same direction is a subset of parallel already. So they are not two distinct statements. You get what I'm trying to say? Yeah, okay. So if you want these two statements, one, they are parallel. Statement number two, they are in opposite direction. Are they really completely different? No, right? This is actually a subset of this. Okay? So over here, we are going to be talking about magnitude. The next statement that we can say is that, once I have this statement, it becomes very easy. Remove the arrows. OF equals to 3 over 2 OA. Simple? By removing the arrows, they revert back to magnitude. This is the topic that we learn on vectors with this arrow on top right. Before we learn vectors, if I ask you about OF, according to this direction, according to this diagram, if I ask you about OF, what will you be thinking about? You'll be thinking about the line segment OF. Specifically, you are talking about the length of OF, isn't it? Likewise for OA, you ask a secondary 1 student, what is OA? He is going to be telling you, he's going to be trying to find the length. That's because that's precisely what it is. If you don't draw the arrow, it becomes magnitude, it becomes the length. If you draw the arrow on top, it becomes a vector. Okay, so this is one way to represent the magnitude. The other way is you keep the arrows on top, but you draw two vertical lines to indicate magnitude. Any questions? Alright, next question. This is 5.4, I think. Do you need help? Take a look at your work. Do you need help with part A?
So,
Yes?
show that ACB and BII, they say show the line. I'm not sure if they use magnitude square.
Okay, hang on first. So for part A, I suppose nobody needs help. Part B, anybody needs help? Can you give me the answer for part B, part 1, AC? AC is 8.4. What about BC? Negative 2.4. Confirm your answers are correct?
Yes.
Okay, so now to show that ACB is 90 degrees, ACB, we are trying to show that this angle is 90 degrees. Based on whatever we have learned, what are some things that are related to 90 degrees that we have learned? Okay, so just brainstorm. Okay, we've got our Pythagoras theorem. What else do we know?
Square rectangles.
Huh? Okay, squares and rectangles. Okay, you got trigo. Over here, dua, ka, so. Okay, what else? What else do we know? Something, anything about right angles. Just throw out everything.
The angles at the side must match 90.
What angles in the side?
90 and the two angles at the side.
Okay, what else? Racy, do you have something to say? What triangle? Uh-huh. So there was a right angle triangle, is it? Okay, like this is a right angle triangle. What else? What else? Something else. Something about circles. Something about half a circle. Something about half a circle. What's that? What's that? What is that? Angle in a semicircle, right? Any more? Is there anything else? Hello. Angle in a semicircle. This one 90 degrees, right? Okay, is there anything else that I missed out? At the moment, I only can think of these things. Okay, so all these, they are possible for us to show that something is 90 degrees. At least there is a relationship. What are we going to choose from here?
Pythagoras.
Pythagoras. Yeah, it sounds like this has the highest chance of it happening. But what exactly does Pythagoras' theorem state? How does Pythagoras' theorem start?
The square of each side.
No?
A squared plus B squared
No.
plus C squared.
How does Pythagoras' theorem start? Yes? Huh? You start out knowing that it's 90 degrees. In other words, for a right angle triangle, that's how Pythagoras' theorem starts. For a right angle triangle, you know that it is right angle first. Then they tell you that, oh, the square of the hypotenuse, meaning the square of the longer side, is the sum of the squares of the other two sides. Right? That is if we know it is 90 degrees. But do we know that this is 90 degrees?
No.
We don't know. Then how? So can I still use Pythagoras' theorem?
Yes, Pythagoras.
The converse of Pythagoras' theorem. Now we're going to reverse it. If I can prove that the longer side, I square it, it's going to be the sum of the squares of the other two sides, then by the converse of Pythagoras' theorem, it must be 90 degrees. Do you think it's possible over here?
Yes.
Okay, done. Don't need me to show you how, right?
So, but then, my working is AC times the magnitude square plus BC magnitude times square equals 100 because that square
Equals to
100 which is equal to 10 square.
100. So you work this out already.
Yeah.
Okay, then equals to 10 square. Then
Equals magnitude AB square.
this is equals to magnitude AB square.
That's it proven.
And then
By converse, ACB is a right angle.
okay, presentation can be improved. So instead of writing this, we remove this. We say that AB, the magnitude is square 8, and we also get 100. Okay? I'm assuming that his calculations are correct. Is it really 100? Is it really 100?
Yes, right. Say yes.
Okay, so the magnitude of this is square root of 80, right? The magnitude of this is square root of 4 plus 16, 20. Square them, 80, 20, 100, yeah, correct, 100. Okay, now, based on this, since the magnitudes are the same, then we say by the converse of Pythagoras, go and spell it out, theorem, angle ACB equals 90 degrees, shown. Next question, 8. Part A, need help?
Yes.
Part A, are you sure?
Yes.
Show that ACB equals to DAC. DAC. Cosby, do you have the answer already?
No, I don't.
Okay, now I need to show that these two red angles are the same. How do I do that? Definitely must make use of information from the question. These two angles are the same, given as shown in the question already. BAC and CDA. Okay? AD is 9 over 5 of BC. What can we extract from here? Parallel. AD is parallel to BC. AD is parallel to BC. These two are parallel. Do we know the ratio of their magnitudes? Which one is 9 units, which one is 5 units? Okay, this one will be 9, this one will be 5. Okay, so if these two are parallel lines, yeah, alternate angles lah. Okay? Sian, any question? Presentation, can you all do it yourself? You better be able to do it. Part B, explain why they are similar. Okay, the angle, similarity test. Okay, now part C, do you need help? Who needs help for part C? Square? Square. So you mean the square the sides? Square the ratio of the sides. So your answer is? Okay, your thing is the square of the ratio of sides, right? So what's the answer? 25 over 81. Check the answer at the back. It is. Okay, so gonna make use of ABC and DCA. Draw out ABC. ABC. The next triangle is DCA. Draw the triangle but bigger in the same orientation. Since we go this way, A to B to C, then we go D to C to A. Then we fill in all the information that we have. In this case, it is just a ratio. This is 5. AD is 9. AD over here, this is 9. Okay, so far? So if I want the ratio of area of the small triangle to the area of big triangle, I need the square of the ratio of sides. Do I have ratio of sides over here? Where? Don't have one. Yes? Like this? Like this, is it? Where parallel where?
So it's like draw like that, right? Then after that, the angle is like the same lah. Then after that, this one is parallel to this one, right? That means they can prove that it is a parallelogram already.
So you're just focusing on this side?
Yeah, then after that, this one is the height lah.
Height,
Then they are the same. Then after that, become like that.
Yes, it can work. Okay, so Sihan has one method which will work, but I'll continue to show you for similar triangles. I need the ratio of sides. So in this case, I notice that AC appears over here for the big triangle. AC appears for the small triangle also. Okay, so now I'm going to take small triangle over the big triangle. AC over DA is equal to AC over 9, right? This is considering this side of the triangle. The next thing that I can have is BC, which is 5, over, C to B, which is 5, over AC. Should give us the same ratio. The next thing we write will be from C to B over AC. This is 5 over AC. Okay, these are ratio of two sides. And because they are similar triangles, these two must be the same. They must be equal. AC over 9 equals to 5 over AC. What do you think I can find from here? I got one equation, one unknown, isn't it? So what can I find? AC squared equals to 45. Right? So AC must therefore be equal to square root 45. But take note, these are not lengths, these are ratios. So AC is square root 45. This is also square root 45. Now can you find ratio of length? And then after that we square, we should get the ratio of area, isn't it? Okay, let's choose any of the sides that we want now. We have two options to choose from. This area will be ratio of length and I square it. Let's choose AC. 45 over 9. Resulting in 45 over 81, which is 5 over 9. Okay, so this is how I did it before you guys gave me the clue that they have the same base. And we can just consider the height, and we see that, oh, it's just 5 to 9 lah. Straight away get the answer. But this is another way to do it. Yeah, one step better lah. But sometimes you can't see, then you must know how to come up with other angles to try and do it. Yes, Tracy? You don't get the same base argument. Okay. Sihan, are you confident of explaining to him? No. Yes. Why you say no? You Sihan. Okay, next. Question 9.
How do I find CG?
So you mean part A you need help?
EF can find CG.
EF is, okay. They're all the same. Okay. DG is V. EF is just 1/3 U. Can do already. Racy, you understood the previous part already? Okay, so part A, nobody needs help. Part B, anybody? None. Part C? None. Part D? Part D? Also none. Okay, I think we have just one last question. What are the questions over here? Part A, anybody needs help? Part A, there are 3 parts. None. What about part B? What are the 2 facts that you have about DB and NB? Okay, so for part B, you should realize that they are collinear. So the first fact that we can write is that DB and NB lie on the same line. Okay, so this is one fact, isn't it? But they said 2 facts. So what is your next fact? Are you going to be talking about direction, parallel, or magnitude? Magnitude. You talk about magnitude. What did you all have for DB? .4, question 11, part 2, 2 over 5, 2p minus q. Okay, so this is dB, NB, part 3, 2 over 3 of 2p minus q. Okay, so we want to express one in terms of the other. There are a few different approaches you can do, but this is what I will do. Right, NB. I know that they are going to be parallel, so it can be in terms of dB. Then use inspection. Look at the fractions. What should be inside here? Okay, so you can just write them down. 2p minus q equals to a blank. Then dB is 2 over 5, 2p minus q. So it is kind of like our integration, right? I taught you all how to, after your differentiation, work backwards, go and find the integration. So what should go into this blank over here? I do not want over 5. I want it to be over 3. So what should I put in this blank? 5 over 3. This goes into the blank. So that your 5 and 5 will cancel off, you're left with 2 over 3. Okay? So inside this blank it is 5 over 3. Based on this, the other fact will be that NB is just 5 over 3 times of dB. So without the arrows, this means the magnitude. And that's the end of our EMAT